Oxidation-reduction reactions. Oxidation-reduction reactions involve the exchange of electrons between atoms and ions. So we have electrons moving. Okay. Here's a thermite reaction right here between iron 3 oxide and aluminum. That generates a lot of heat. Now what's thermite? Well, I looked it up. It's a composite of metal powder, fuel, and metal oxides. When you apply heat to it, you get an extreme exothermic oxidation-reduction reaction, used a lot in fireworks. There's a shorter word. Instead of saying oxidation-reduction all the time, we say redox. I guess because oxred doesn't sound as cool. But bottom line, we're transferring electrons from one element to another. So let's look at the reaction where you have aluminum combining with oxygen to form aluminum oxide. Originally, aluminum has zero charge, so does oxygen. They're in a neutral state. When they form the compound, aluminum is using its valence of +3, oxygen is using its valence of -2, and what's going on here? Each aluminum will lose 3 electrons. Each oxygen is gaining 2 electrons, so we have a stable compound. And the oxidation piece is the element that loses electrons. The reduction is the element that gains electrons. So what's a nice way to remember that? Well, if you gain electrons, that means you're going to have a more negative charge. You're going to lose charge. So you're reducing. So a good way to remember that, reduce is when you gain electrons and you get more negative. Now, of course, because of the conservation of matter, mass, the electrons lost or gained must be balanced in a redox reaction. So let's look again here. We have 4 aluminums in the beginning. Each one of them, so here's 4 times aluminum, 4 aluminums. Each one loses 3 electrons. 4 times 3, 12. Hopefully the oxygen picks them all up. Well, let's see. Each oxygen will gain 2 electrons. There's 6 oxygens, right? 3 times 2. 6 oxygens, each one gains 2 electrons, 6 times 2, 12 electrons gained. Excellent. In order to determine if we have a redox reaction and which element got oxidized or reduced, you have to track the charges or the oxidation states of the elements throughout the reaction. So if we have here zinc getting together with hydrogen, and then on the other side, zinc is turned into a +2 ion and hydrogen is back to its neutral state, we write the oxidation states down here. Zinc is neutral, that's 0. Hydrogen, each one is +1. Here, zinc is +2. Here, hydrogen is 0. So the charges on both the zinc and the hydrogen change. This is definitely a redox reaction. Electrons have been transferred. We've already done this and maybe it seems obvious, but we're going to state it again here. All elements in their standard or neutral state have an oxidation state of 0. If the element has a charge listed, this is its oxidation state. So here's standard and neutral states, so the oxidation is 0, 0. Here they show you that sodium is +1. That's its oxidation state. Fluorine is -1. That's its oxidation state. If the element is combined with other elements, the oxidation state has to be deduced, kind of like a Sherlock Holmes thing. So you can use your periodic table, your knowledge of ionic compounds, and some math. Here are some general guidelines. Rule 1. The charges of all the elements in a compound have to add up to the charge of the compound. So here's zinc oxide. There's no charge, it's neutral. So the charge of the zinc plus the charge of the oxygen have to equal 0, has to stay neutral. Nitrate. In this case, this compound has a charge of -1. So the charge of the nitrogen and the charge of the oxygen has to equal -1. Okay, now let's add another rule or guideline. The first one we already did. The charges on all the elements in the compound have to add up to the charge of the compound. So now, use your periodic table, find the charge on the anion. So that's right over here. Zinc oxide, oxygen is the anion. and use this and what you know to be the charge on the whole compound. This will enable you to find the charge on the cation. Typically the cation is written first and the anion second. So we get this information from the periodic table. That's oxygen's oxidation, -2. We know the overall compound is 0, and we need to find zinc. So we need X plus a -2 equals 0. That means zinc has to be +2. So zinc has a +2 oxidation state. Let's find the oxidation state for nitrogen in nitrate. So let's start with the nitrate charge. It's a -1. We go to the periodic table for the anion, which is oxygen, and we find that it's -2, but we have 3 oxygens. So we multiply 3 times -2. Now we then have to add the cation and the anion charges to get -1. All right, so what we have is -1 equals -6 plus, we'll put N here for the charge on nitrogen. You solve that equation and you get the oxidation state of nitrogen is +5. And again, we got the -2 from the periodic table for oxygen. Let's do another example, and in this case we're going to use the dichromate ion. And don't be impressed, I looked on the web to find out what this was. You just have to type in Cr2O7, it'll tell you everything you want about it. So that's dichromate. And we're going to start with the dichromate, and we notice that it has a -2 charge. Oxygen, we do that first. We know it has a valence or an oxidation state of -2, but there's 7 of them. So we have 7 times -2. And then the chromine, there's 2 of them. So we have to solve for this question mark to find its oxidation state, but we know we have 2 atoms of chromine. So what we have, we'll do the math here, -2 equals -14. Okay, there's the -14. Okay, plus 2 times X, where X is going to be our oxidation state of chromine. You do the math and you find out that the oxidation state is +6. So chromine is +6, which we got from the calculation, and oxygen is -2, which we got from the periodic table. Find the oxidation states of bisulfide. And again, I searched on the net for that, and you type in HS minus and then chemistry, because HS gets confused with high school. So go ahead and give that a try. Pause if you like. Okay, now we'll pull the answer tab out. Let's see what we did here. We wrote hydrogen, we wrote sulfur, and the first thing we do is find the valence from the periodic table for the anion, which is sulfur, which is -2. And then HS minus, the disulfide, has a charge of -1. So now we have to just do a little math here, and we know that the hydrogen plus, well, the hydrogen oxidation state -2 for the sulfur has to equal -1. So we do the math, my question mark equals -1 plus 2, and what do we get? We get 1. So here's our oxidation states. Hydrogen is +1, sulfur is -2. Sulfur came from the periodic table, hydrogen came from the calculation. Dinitrogen tetroxide. You can either remember how to name that by di for the 2 and tetra for the 4, or you can cheat and look it up on the web. So take a second to work this on your own, and then when you're ready, come back to this presentation here and we'll pull the answer tab out. Okay, so here we go. We look at oxygen because that's the anion. We find its valence, it's -2, but there are 4 of them. So its total state there would be a -8. The compound itself is neutral, so it's equal to 0. And now we do some math. But please make sure you remember there's 2 nitrogens. So we have 2 times the oxidation state of nitrogen minus 8. That's what oxygen contributes. That has to equal 0. So N, 8 divided by 2 is 4. So the oxidation state of nitrogen is +4. And oxygen is -2. -2 coming from the periodic table and the +4 coming from our calculation.